Hi, today we are going to see one more topic from Teradata, that is Teradata architecture. Yesterday we have seen about the Teradata architecture, but it is an introduction to the Teradata architecture. I have not fully explained the components of the architecture. Okay, this is the diagram of the Teradata architecture. Already I have told you it contains three major components, that is parsing engine, message passing layer and AMP. Whenever the user writes the query, it first the parsing engine receives the query from the client and it parses and prepares the execution plan and dispatch it to the AMP through message passing layer. The AMP retrieves the data from the disk and passes on to the parsing engine through message passing layer. From parsing engine it goes to the user, and this is the diagram. From the diagram itself we can easily understand the basic architecture. And the parsing engine is further divided into three major software components, that is parser, optimizer and dispatcher. Parser, what the parser is doing means, the parser interprets the SQL statements. That means it checks for the proper SQL syntax. If syntax is okay, then it checks for the system tables, whether the particular person has got the particular user has got the access rights and whether that particular table exists physically in the that means particular table exists in the database or not. Then it prepares the plan by using the optimizer. The optimizer is responsible for developing the least expensive plan. That means we need one plan to retrieve the data from the database at the quickest possible time. That plan is prepared by the optimizer. That plan is actually converted into executable steps to be performed by AMP, which are then passed to the dispatcher. Optimizer enables the Teradata to handle multiple complex ad hoc queries efficiently. A dispatcher, the name itself we can see, it dispatches the answer response and it receives the steps from the optimizer. Dispatcher actually controls the sequence in which the steps are executed and passes on the steps to the binet. It is composed of two things, one execution control, other one is response control. Execution control receives the steps from the parser and transmit them to the appropriate AMP for processing. Processing means retrieving the data from the disk, and it receives the status result from the AMPs while processing the step and make sure that particular process is completed. After that, the response control returns a result to the user. Okay, and depending on the nature of the SQL request, a step will be sent to either one MP or more than one MPs, that is broadcast to all MPs. Binet, actually binet is the message passing layer. If it is a single node means it is a software component. If it is a multiple node means it is the hardware component. The binets handle the internal communication of the Teradata database. All communication between PEs and AMPs is done via binet only. Okay, when the PE dispatches the steps for the AMPs to perform, they are dispatched onto the binet. From here, the message is routed to the appropriate AMP where results, set and status information are generated. The response is also routed back to the requesting PE via binet only. It contains the dispatch request. Depending on the nature of the dispatch request, the communication between the two nodes may be classified as broadcast or point to point. Broadcast means all nodes, and point to point means a particular specific node. And parallel database extension directs the message to the appropriate AMP on the node. PD helps us to message to the appropriate AMPs on the node, and binet has got its own features like load balance, scalable, high performance, etc. Scalable, that is whenever we add node, there won't be any performance issues. Load balance means traffic is automatically and dynamically distributed between the binets. High performance, the performance will be increased drastically. Okay, and it helps the Teradata parallelism, that binet. AMP is access module processor. Already I told it helps to store the data and retrieve the data from the disk. And there is one subsystem database manager which helps us to lock the table and create, modify or delete, that means data definitions, and insert and delete the data or modify the data, and retrieve the information returns to the dispatcher. From dispatcher it goes to the user. And for your information, Teradata always performs all tasks in parallel, providing the exceptional performance. Greater the number of tasks processed in parallel, the system gives better performance. And this is the detailed explanation of the Teradata architecture. If you want further explanation, or if you want to read further, then you can refer to the manuals, Teradata manuals available in the Teradata site, and you can download and you can refer it. Thanks. Bye.